It looks as though everything's working. Yeah, there's got a bit of oil. All right, well, we need to analyze that, okay? I'm surprised that there's so little, but let's check why and find out what the problem is.
Professors David Glasser and Diane Hildebrandt are directors of the Center of Materials and Process Synthesis at the University of the Witwatersrand. They head the team that refined the Fischer-Tropsch technology. It can now be applied in coal-to-liquid processes at reduced capital and operating costs and decreased carbon dioxide emissions.
We're looking at small scale, which means much cheaper. You don't need billions of dollars to get into the market, but maybe millions, and that's more suited to often in developing country economies. It's set up in terms of being robust and simple. You get your efficiency from how you put things together, not from having an extremely high-tech piece of equipment that if it breaks down you can't fix locally and you'd have to ship off somewhere. And it's also particularly suited to developing countries because the way we managed to improve efficiency on our process was to make two products, both fuel and electricity. And in developing countries, they are short of both fuel and electricity, and having one process that supplies both is a huge advantage. And furthermore, what we're able to do is switch the relative proportions of fuel to electricity. The importance of that being that often in developing countries, and for example South Africa, meeting peak electricity demands is a problem. I mean, we all had the blackouts a few years ago that, winter evenings when we switch on stoves and heaters, the lights go out all over the city. And if you can have plants that when there's peak demand for electricity can switch to make mainly electricity, and then when the electricity demand drops can switch back to making fuel, you have a technology that's able to balance local electricity demands and therefore help supply infrastructure and a base and help with the peak loads of electricity.
It can be used anywhere in the world as long as there's a carbonaceous resource, a fuel source, like it can be used with municipal waste, it can be used with coal, with natural gas, with anything which has a carbonaceous material.
The Golden Nest International Group is funding the project at a cost of about 75 million rand.
The Chinese government realized that they had a shortage of energy, particularly liquid fuels, and they were reliant on importing liquid fuels. And what they were looking at is to find a technology that could help them produce liquid fuels internally to cut their reliance on imports. And South Africa has the reputation for being the leader in Fischer-Tropsch, which is the process that takes carbon materials like coal or gas or waste and turns it into fuel and electricity. And so they came to Wits asking if we could help them.
The Fischer-Tropsch is converting syngas to liquid fuel. Now we have a feed which...
A number of Chinese students are completing their PhDs at the Center of Materials and Process Synthesis. Craig Griffiths is one of the South African PhD students who accompanied the team to China for the startup and commissioning of the plant.
Basically, the plant is a process where we take synthesis gas. Synthesis gas is a mixture of carbon monoxide and hydrogen, and we run it over a catalyst to produce liquid hydrocarbons. This is a lab-scale setup of a system. We take the feed gas in here, which we combine the hydrogen and the carbon monoxide, and we send it through one of these microreactors. We've got a coil heating around it to get to the right temperatures. Inside is a catalyst. Once the reaction occurs, we form liquid products and waxes, which collect in this container at the bottom. This is a separator, and it separates the liquid products from the remaining gas, which then goes into another separator, tries to recover some extra products before we take the gas and we vent it.
Besides less carbon dioxide emissions, the new technology has a number of other benefits.
Furthermore, many of these waste materials would otherwise have ended up in the environment as carbon dioxide, but we wouldn't have recovered the energy in them. And so we would have produced the carbon dioxide and wasted the energy. With this process, we're able to recover the energy that was stored in the material and turn it into something useful along the way, which is why it's a benefit to the environment.
Which brings us to phase 2 of the project.
Okay, well, one of the big problems with Fischer-Tropsch technology is you produce quite a lot of carbon dioxide for every ton of liquid fuel you produce. So the phase 2 of our project is what can we do with this carbon dioxide? Now, one of the big interests is algae to produce biomass. So what we have here is we've got different strands of algae growing. We are looking at the moment, we're looking at local sources of algae, and we're just trying to see how they grow and what are the important factors, what limits their growth, how does pure carbon dioxide affect their growth, and we're just trying to get a better understanding so that later on we can take an algae plant, put it at the end of our chemical plant and start producing biomass. This biomass is then useful, you can use it as a fish feed and then produce agriculture, you can look at producing biomass for further fuels.
The pilot plant has been successful in China, and the team hopes to roll the project out commercially.
What we would really like to do is work with a local municipality in South Africa to look at taking waste, that's the garbage you throw out from your house, sewage and so on, and using that as a source of a feed. Why I believe this is important in the Southern African context is I think our local municipalities often have a problem in capacity in running our sewage plants, running our dumps, and the dumps themselves, in the end, they often cause problems with our water supplies. And so if we can show that this technology can be used, we have a way of actually handling a waste which costs money for the municipalities and in the end for us as taxpayers, and actually turn it into something that's profitable. We'd like to do that in South Africa. We would also like to look at working with government and maybe identifying small coal reserves where we can also implement this.
The collaboration of China with South Africa on this project has hopefully created an open route for the two countries to benefit from each other in future initiatives.
As a developing country, we've still got lots of challenges ahead of us, but it does give us an opportunity to stretch our brains and develop new interesting technologies. We aren't able to throw a large amount of money at a problem, so we become very clever about what we do, and it helps us develop interesting technologies.